up a class period, third period, for study skills. So if you are below sea level in this class, or even if you are not where you want to be, and you can open up third period, that's going to be a period where I will help you with your Learn Smarts, I will help you with your homework, I will help you with whatever. Okay? So if you can open up that third period and get into it, and you're struggling, that would be a good thing. Okay? Because I'll be here to help you. Now, if you can't, it's still okay. We're going to have Thursdays after school, 2:30 to 3:30 at Mrs. Poultry, and I will both be running at the same time. A days will be in Poultry's, B days will be here. I'm also going to do a special review for this chapter on next Thursday, so plan on it. I'll also have that Friday tutorial be an extra review if you need it. Okay? Yes.
Oh yeah, so does it count as an elective if you transfer into it?
Yeah. Okay, so if you would like to, and for some reason your counselor won't let you in, come see me, because the CTE coordinator said she will make it happen. Okay?
So even if I have history required to graduate.
Well, you'd have to move it to another period, but she will work it around. She won't let the counselor sort of bully you out of it. Does that make sense?
Okay.
If you want in it, we'll find a way to get you in. So make sure you let me know. Yes.
So there will be a review every Thursday now.
There'll be a
Or, like,
period that you can be after
Time frame
school
for tutoring and
with
stuff.
the two of us in there that you can come
Okay.
get help. Yeah.
Oh, I'll be there now.
But having said that, know that I'm here most days, 6:45 in the morning. I don't have hardly anybody come for help in the morning, so that's a good time if you want one-on-one. I'm also after school most days. I will be putting up on the board what day I will not be here because I am also in school taking classes. So I can be certified to teach the biotech and the medical forensics through the state. So I have to go down to Slick, and like Wednesday I spent from 8 a.m. till 10 p.m. in lab doing labs down there. So I could be certified doing labs, yes.
Wait, do you have homework?
Oh yeah,
What kind of?
like several papers researching SNPs and different kinds of DNA things.
Oh.
And their MLA and their PPA and all that kind of stuff. So, know that I'm under stress too. I'm just like you guys do stuff, but I'm wanting to help you make it where you need to be. So I opened up this period. So if you need extra help, specifically those of you that are below sea level, okay? We want to make sure you're above sea level so that it will count as prerequisites to other classes. Okay? You have half a year. We've got 7 out of the 13 chapters still left to do.
If you are if you just get better on your test, can you bring it up?
Well, you want to get better on your tests. Make sure you're doing better on your Learn Smarts and homework. Learn Smarts and homework are 20% of your grade. Labs are 20% of your grade. That's 40% of your grade. So if you don't do those, if you don't do your Learn Smarts, you don't do your homework or your labs, there's no way you can pass. That's it. There is no way you can pass. Okay? Then you got your tests. Even if you got 50% on every test, so you got 40, and this is where 60, that's 70%. Right? So even if I got 50% on every test, I still can get a decent grade. If I've done my homework and I've done my labs and done well on both of them. Okay, so yes. Oh yeah, B plus will get you into most every thing. B minus is the bottom you want to be. Okay, that's why I said if you're not above sea level, we really need to get you into this study skills class and get you help so we can get you up to where you need to be. If you're above B minus above, I'm not as worried about you. But if you're below B minus, I'm worried about you. Okay, I want to get you that extra help. So plan on coming either before school, after school, getting into this class, whatever it takes, let's get you up. Okay? Let's get those Learn Smarts done, let's get those homeworks done before the tests. Okay, I know a lot of you have just been pushing off, I'll do them later. They help you for the test, prepare. Okay? So don't push them off. Okay, and that means that I'm done talking, I guess. Okay, all right, let's go ahead and get started. We ended on this, and I know some of you were confused. If you don't have a calculator, go grab one of these or these, one of the two. You'll need calculators today. Please grab them. This is a very heavy math unit. Okay, this is a very heavy math unit. So we'll be doing the Boyles part, law part later. We'll need those kind of calculators. But we'll use that in the past.
Wait, we need calculators now?
You'll need calculators out now, yes. You won't want to use your phone, you want to get your calculator out.
If I'm too lazy, is this alright?
What did I just say, Parker?
Yeah. I mean, it's like down here, so.
Okay, what I just said is phones will not be enough. Please make sure you have a regular calculator. If you don't, please come borrow one from up here or one on top of the computer. Okay, I just unplugged them so they are charged. Okay, so I showed you. Okay, guys, you gotta calm down and focus. Okay, last time I showed you a special app on your calculator. Before I review that again, I want you to show you the old way to do it. So in case for some reason you can't get to it on the calculator or it doesn't look right, you can double check. It's just simple, that factor label we did, you keeping track of the units. So here they want you to do, we started doing this last time, I know it's probably already partway in your notes, but I'm going to back up and do it again. Okay, so if I have 28.6 inches of mercury, these are the conversions that I need to be able to do all of these calculations at the bottom. I want to get rid of inches of mercury. It'll go on the bottom, right? So I look down here for inches of mercury, and it's 29.92. So I put 29.92 inches mercury on the bottom. I want to get to ATM. What do I put on the top from this list? 1 ATM, because I want to get to ATM. So I just put 1 ATM on the top. Inches mercury will go out. Then I just take the 28.6 divided by 29. I've got my answer. So let's go ahead and do that.
Remember the way like you showed us how to
I'll show you that in just a minute. I want you to do old fashioned because a lot of kids were going, well, how does that magically appear? You need to know how it does so that you can double check and make sure you're doing it right. Because a lot of them were just picking a number and it wasn't giving you the right number. Okay? So, you got the answer?
What is the number on the bottom? 0.92?
92.92. It is right here.
Oh, that's just
Okay, did you get an answer?
So is that?
Is that what you got?
You should come work up here.
Does that make sense? Yeah, because this is just less than this, so it'll be just under 1. Right?
What is the ATM set for again?
Atmospheres. Okay, we're going to do it again right here, but with torch. So I'm going to still start with the 28.6, and it's still inches mercury. Okay, I'm still going to use the 29.92 inches mercury because I want to get rid of it. It's going to go on the bottom. But on the top, I'm going to put torr. Now, this is what you need to know. Torr is the same as millimeters mercury. Torr was just the guy that first measured pressure in millimeters of mercury instead of inches. Yes.
But for the 28.6, like no matter what problem, would you always put whatever it gives you on the top?
Always start with what they give you. Always start with what you give you, and it usually doesn't have anything on the bottom, unless it's a unit. Yes.
So is 1 ATM congruent to like 14.7 PSI or no?
Yes.
Oh, everything on that table is
They're
congruent.
all equal to each other. So if I want to make a fraction, I can put any one of them on top to any one of them on the bottom.
That is so
You can do
nice.
any of them.
Yeah, any of them, because these are all equal to
And
each
they're
other.
all ones.
Right,
all just
it's
ones.
like equal to 1. If I put anything from that list on top and anything from that list on the bottom, it's equal to 1. So I like to put this on my card. This is something I like to put on my card. Because sometimes I'm in the middle of a calculation and I don't want to have to go into side tools. Because then if I go into side tools and get all the way in there, then I've got to get all the way back out to do the calculation. So if I know this, it's really simple and easy. Okay? So what would I put on the top to get to torr?
760 torr.
760 torr. So here, I'm going to take this times this divided by that. Do that. See if you can get the calculations correct.
Over 29 into
Got an answer?
726.4.
Okay, does that make sense? Is it going to be bigger than 760 or less than 760? Less. Good. Okay?
Wait, what is the less and greater mean?
Because this number is less than this number, so when I divide them, it's going to be less than 1. And then I'm timesing it by this, so it's going to be less than 760. Okay, let's do the PSI. Again, starting with what we have, 28.6. And if you're writing this in your notes, it will help you to see how you're getting this. Again, dividing by the 29.92 inches of mercury. But this time we're looking for PSI. What do we put on top? What is PSI? Does anybody know?
Pounds per square inch.
Pounds per square inch. Good.
That makes much more sense.
Okay, what do I put on top? 14.7 PSI. So again, inches mercury go out. Little less than the 14. What do we get?
Sorry, can you see a Pepsi?
Pounds per square inch.
Okay, pounds per square.
Okay, so it should be just less than 14.7. What'd you get? Oops, I put that one up first. Sorry.
I don't care.
So 3 significant figures. So 14.09 would round to 14.1, right? Okay, so the same kind of thing over here. I've already given you that answer. Set them up real quick. I want you to practice. Set them up, and then I'll take you through how to do it with calculators. Yes. So I don't put that on the board. I lose it, as I said.
How hard do I have to
So it doesn't matter what else you want, it's on top of it. Give me some this number. Okay.
You can work in my department. It's not guaranteed right now, but I'm pretty sure it's all managers. I did really good last year. So I'm 4%. We have a lot of fun. There's days where it's really technical. Actually, Tuesday we don't do that is security. Their fault.
Sugar and cheese.
I would love to start doing this. No, I gotta have that park on. It's like, no, you know, why do we have to park here? Please. You can't park in the front. I've had guests ask me stupid questions. Of course, I have to answer. Sometimes it's just like your brain misfires.
Okay, how are we doing?
Really great.
Okay, now I want you to try it with the side tools. Okay, so you go to apps. On your calculator, go to apps. I want you to practice it with the science tools too. So you can double check yourself in case you get onto the test and you're going, I think that's how it does it, but I want to check. Okay? So this is a way to double check. You got the side tools? Make sure you're in English. What are we doing? What are we doing? What are we trying to do? We want to convert units, right? So click on unit converter. What kind of units are we trying to convert? Pressure, so click on the pressure. Then you're going to put in the 28.6 millimeters mercury. So you want inches mercury. INHG is what you're looking for. INHG, find that. Okay? And then you want to click to, what do you want to go to? And you find it, and click it, and double check it.
But then, can we go away with this?
But here's the key, here's the kicker. Here's where I see a lot of kids having problems. Listen to me, this is important. Make sure you take it out of scientific notation. Because it puts everything into scientific notation. So if you times it by 760 millimeters mercury, it's going to give you 1 point whatever or 7 point whatever. And if you don't go times 10 to the whatever at the end, then the calculations are wrong. That's why I showed you the old school way first. This is just a way to check it. Yes.
So is it ever going to go longer, like how there's like multiple things, or is it just the?
You're just usually changing from one unit to another with pressure. And then you're using that pressure to put into a new equation. Yes.
For that one, how do you know that 29.82 or 92 is on the problem? Like, why isn't it?
Because it's what is, since I was in inches mercury, I have to find inches mercury here to put it on the bottom to get rid of it. Okay, so whatever I want to get rid of goes on the bottom, whatever we go to goes on top. Yes.
How do I change it
I
back
got
into
taken off their list before they hit it.
from science?
I got called by college.
So in your sign tools you can't. It just always reports in scientific notation. Okay, so that's the downside of sign tools. It always reports in scientific notation. If you're okay going back and forth, that's great. If not, go back to this way and put this on your card. Okay, I would put that on my card anyway. All right, we okay to move forward? I'm going to put the answers up. Let's see if you did okay on the answers. How'd we do?
Mine is literally.
Thumbs up, I'm giving this. Thumbs down, I'm not. Thumbs sideways, and still healthy. Yes.
I get it on measure paper, like it's a calculator. I don't use it.
Okay, so I would stick with the paper then. And then if you get time extra, come in on that. Okay? All right, let's go forward. Pressure. We're going to talk about pressure. You guys are under so much pressure, right?
Freaking
About 760
atmosphere.
millimeters of pressure. That's air pressure. Okay,
Yeah, no,
stay with me. Pressure is the force exerted over an amount of area. Yes. Yeah. Okay. You're just waving at me. Okay. All right. So for gas, it's the pressure over a given area also. What causes the pressure is how many times the gases collide with the wall of the container. If they collide a lot, then the pressure goes up. If they collide every once in a while and slow down, the pressure goes down. So with gases, it's how fast are they moving? What is their kinetic energy? Right? We learned that last time. What's their kinetic energy? Is it quick? Is it high kinetic energy? Or is it more potential energy with just a little kinetic energy? Okay? So, collisions of glass particles with each other and the walls of the container, that's what makes pressure. All right, we good? Good to go? Yeah. All right. So when gas particles collide with the walls of the container, they exert pressure. Pressure P is the force that exerted over an area. We had several ways that we measured pressure. Atmospheres, torr, inches of mercury, PSI. There's tons of different ways, and you need to be able to go back and forth between them. Pascals and kilopascals. Pascals with a capital P is a kilopascal. Okay, going forward, okay? All right, so looking at a ballerina. The ballerina, if they stand flat-footed, the area that they're in contact with the ground, by their weight, gives us a Newton per centimeter squared force, pressure. If they go up on toe, the pressure becomes even greater. So if you're a ballerina and you're on toe all the time, they end up getting hammer toes. They end up getting not very pretty toes. Okay? If they go up on one toe, that's twice the amount of pressure on that toe. Okay? Because they're in a very small amount of area. Okay? The force coming down was the same, but the area that it was going in is less. Yes.
What about when they jump?
then you're going to have more force coming down because they got weight times gravity coming down. Yes.
So how do we know what to put, like, are we gonna have to do those on the bottom?
No, I just want you to think in your mind, okay, less area, same amount of force, the pressure's going up. Okay? All right, so stay with me. Stay with me. Okay, so here we have a vial, and it has a specific volume at a specific temperature and pressure. If we increase the amount of weight, which means I'm going to increase the pressure, what do you think is going to happen to the temperature in the volume? Okay, how? What happens to temperature? Okay, it will rise because we'll have more collisions, right? What about the volume? Good. If I'm putting more pressure on, squeezing it, it's going to go down. Volume. Okay, got it? Okay. What about if I increase the volume but keep the pressure the same? What's going to happen? So I increase the volume, kept the temperature the same. What happens to the, increase the volume, kept the pressure the same. What's going to happen to the temperature? It'll decrease because my collisions with the wall will decrease. Okay? We've got an increased temperature here, though. That's in order to hold it at the original pressure. So what I was talking about was different because anyway, we'll go on. We're just sort of visualizing what we're going to talk about in just a minute. So, number of moles, that's how many particles I've got in here. That's represented by N in the equations we're going to be talking about. We've got a volume here. If I increase that volume to 2 the amount, then in order to get that at the same pressure, I'm going to have twice the number of moles. If I 3 times the volume, then I'm going to need 3 times the amount of moles.
What does N stand for in that?
N is the number of moles. Okay? I don't know. I know why we didn't use M. Why don't they use M? We use meters. We use all the molarity. Yeah, whatever. Okay, so we've got increasing energy, kinetic energy. So solid, not much, it vibrates. Liquid, a little bit more because it's moving around. Gas, even more. We get to plasma, it's extremely high energy. Okay.
Can we talk about plasma in this class since it is like the
Very little.
health class? Did we talk about the plasma in our body or the plasma?
No, plasma in the universe, like it's split into positive, negative, it's now not an atom.
Is it cool?
No, it's very hot.
Oh. Like.
Okay, guys, we'll get an activity here in just a second, but you gotta stay with me. I know it's Friday and everybody's having a hard time focusing, but try really, really hard. It's snowing. Okay, here we go.
I still need my math homework. I still need a drink.
Okay. Explain each of the following observations using kinetic theory. Could you tell me ideal toddler rules? It's a real review from last time.
Oh, we touch everything,
So what is that?
like, whoa.
Straight line motion.
Okay.
Straight line motion.
Straight line motion.
It's very volatile.
And then,
Yes.
You bounce back after collision.
Okay, so collisions are elastic.
They're ideal.
They don't attract or repel each other.
They don't attract or repel each other. Somebody remember that.
they're average.
Okay? For ideal. There's 2 more.
They're all medium.
Average temperature.
Okay, so what about temperature? You're getting there.
They're super.
If it's cold outside,
They're so.
they don't want to move much, so they slow down. But if it's warm outside, they want to play and go. So average kinetic energy is related to temperature. That's the 4th one. Now what is the last one? Yes. Yes.
I think you were right.
That's what we just did.
When you look at the volume, like they have the volume.
Yeah, they have no volume. They can sit on my lap and I don't have to pay for them on an airplane. So we've got the 5 toddler rules. Okay, get real. What are the 3 teenagers rules?
Space. Yeah.
Okay, so what was space?
Space.
I take up
Have their own
I
volume.
take up my space, so I okay, attract and repel, that usually comes real fast,
And then their collisions
Are elastic.
are not elastic. We've learned in driver's ed that we cannot crash into things and bounce back and have no problem, right? Okay, so that's 3. Okay, how do I get teenagers or real gases to act more ideal?
The summer.
Summertime. Okay, so tell me about summer. High temperature.
You get to hang out with whoever you want.
Low pressure meaning. Oh, a low pressure.
Higher volume.
What helps with low pressure though? The next thing.
Stress.
I don't know.
And
Less pressure.
it's
You
the,
hang out with who you want. So I can hang out with people that are, instead of being put in classrooms where I have to interact with everybody, I can choose who I interact with. So non-polar. Okay, non-polar. Okay, so now using those. Gases have low densities. How can I explain that with kinetic rules? Gases have low densities.
Have more room to grow.
Okay, what?
Gases have like more room to grow.
You're on the way. They have more room to what?
compact, like they have more, like they can get pinched.
They can be compressed, right? So because they can be compressed, give me a little bit more.
More collisions.
There's less collisions.
There's less collisions.
Less volume?
They don't take up very much volume. They have lots of open space around them. Okay? So they have low density. What is density? How much I have in an area. So if I have mostly empty space and the volume of the gas is very small, then if I take a square meter of it, there's only going to be a few gas molecules in it. Does that make sense? Okay, next one. A gas always exerts uniform pressure on all walls of its container. Okay, kinetic theory, how am I going to explain it?
Repulsion.
Okay, it won't necessarily hurt at the same time. Mateo, what about you? Number two up there, how am I going to explain it according to the kinetic theory? Okay, guys, stay focused. Stay focused. Okay, how are we going to explain this according to kinetic theory?
They have high energy.
Think of toddler rules. They do have high energy. Think of toddler rules.
They're elastic.
Elastic elements?
Oh, they don't.
They don't focus on anything.
Oh, they don't.
So straight line, rapid, random movement, right? Okay. All right, and the last one. Solid, liquids, and gases all expand when heated. How do I explain it with kinetic theory?
More energy.
They have more energy, good. And because they have more energy,
They
collide.
they collide, they expand, they
They're more ecstatic.
have more kinetic energy. Think of that toddler rule with more temperature, I'm more active. Yeah, okay, all right, good. Okay, so if she gives you a scenario, thinking about your 5 toddler rules, your 3 teenage rules, and how to make the teenagers more ideal with 3 other rules, right? So 5, 3, 3.
More vibrating.
You can help remember which one you can explain these with, right? So she gives you a list, and it's not one of the 5, 3, or 3. Don't choose it. Okay? All right, going forward. Gases, blah, blah, blah. Just gave you some visuals. Okay, following statements are best associated with solid, liquid, gas, or gas states. Match the statement with the appropriate state of matter. A. Temperature changes influence the volume of this state of matter substantially. Which one?
Just less.
Gas, yeah. In this state, constituent particles are less free to move about than in other states. Solid. Pressure changes influence the volume of the state more than that of any of the other 2 states. Gas, because I can compress it. I have lots of empty states. This state is characterized by an indefinite shape and low density. Gas. Okay. Gas. Okay, gases expand to fill any container. Random motion, no attraction. Okay, that's ideal, right? Gases are like fluids. There's no attraction. They sort of flow over each other. Okay, gases have very low density, no volume, lots and lots of empty space. Lots and lots of empty space. So think of this visually in your head as you're thinking about solids, liquids, and gases and describing them. Okay, characteristics. Gases can be compressed. That's why you don't want gas in your brake line, right? Because if I have gas in my brake line, if I'm pushing on the pedal, it's just going to compress the gas. It's not going to force the calipers on my tires to close.
So gas has no volume, or
Gas has very, very little volume. Okay? All right. We need to know the difference between diffusion and effusion. Does anybody know what that is?
Diffusion is like it's getting stuff unconcentrated, and effusion is getting it concentrated, right?
Yeah, the first one right,
Yes.
not the second. Anybody will help them?
So,
So diffusion, if I open, and I don't know where it is, my grandmother's perfume. Opened it up. It would spread through the room.
yeah, and then diffusion goes into one spot, doesn't it?
Okay, effusion is why they put that stinky smell in the gas. Why do they put the stinky smell in the gas?
I'm sorry, gas.
So you can
Yeah,
smell it if it
gas.
gets dangerous, or
Gaseous gas.
if I have a leak. So effusion is through a small hole. So effusion is through a small hole that gas can get through. Diffusion is through a room. So it meanders through a room. So I can effuse through a hole in the pipe and diffuse through the room. Got it? Effuse through a hole, diffuse through the room. So this is too big to be effusion, but this little hole in the wall of the pipe would allow effusion.
Can you go back for a second? For
Back.
one more. Sorry. Okay, thank you.
Is that good enough? Okay. And I'm writing.
Yeah.
Good thinks I'm writing again. Okay. So when we have a change in size of a container, we have, if we go from large to small, then it's going to hit the wall more often, and they're going to hit each other more often. This causes an increase of pressure. As volume decreases, we increase the volume, and because we increase the volume when pressure decreases, they have less collisions. Okay? So if we take a big container and make it small, we've decreased the volume and increased the pressure. If you go backwards and make the container large, you've decreased the pressure and increased the volume. Okay? All right, STP. When we were little kids, we used to go up to the gas station and get little STP stickers to put on our wagons. I know, it's been a long time. STP used to be a brand of oil, but it is standard temperature and pressure. You will need to know these. Okay, so it is 0 degrees Celsius. This is different than what we're going to be using standard later. For a gas, 0 degrees Celsius, which is 273.15 Kelvin. And for the equations we're going to be using, everything has to be in Kelvin. Okay, everything has to be in Kelvin because temperature is on the bottom of these equations. And if you divide something by 0, what happens to it, mathematicians? It's undefined, right? Okay, so we have to use Kelvin. 1 atmosphere, that we should have these down again, but 1 atmosphere is standard, or 101.325 kilopascals, or 760 torr or millimeters mercury. Those are standards. So as long as I get it into the standard, I can do STP. So in a problem that we're going to be coming on in just a minute or two, STP is standard temperature and pressure. They don't have to give me the number. I have to know that number. Okay? So I have to know that number. All right. So did we talk about temperature going back and forth between the 3 kind of scales yet? Okay, this is also on your temperature converter, on your side tools, but the hardest one is going back and forth between Celsius and Fahrenheit. You can see on the bottom there's the equation going backwards and forwards between Celsius and Fahrenheit. Kelvin to Celsius, real easy. If it's in Celsius, add 273.15. Okay, guys, pay attention, please, thank you. To the Celsius degree, and you get Kelvin. If you got Kelvin, you want to get to Celsius, you subtract 273.15. Fairly easy. The Kelvin and Celsius scales have the same incremental change. where the Celsius and Fahrenheit do not. The only difference between Celsius and Kelvin is an absolute scale. Does anybody know what an absolute scale is?
There is no negative numbers.
There's no negative numbers, and we have not reached 0 yet.
Oh, that's normal. How cold
Okay.
is that?
Really cold. Negative 273.15 Celsius. Celsius. Okay, so we always use absolute temperature when we do the gas laws. That's really important. If you put in Celsius, you will get a wrong number. That wrong number will be one of the choices. So make sure you change everything to Kelvin when you're doing equations. Okay, let's see what we can do with these. This is real easy. How do I get from Kelvin to Celsius?
Add 3.15.
I subtract it. Going from Kelvin to Celsius, I subtract because I've already added it to it. Okay, so what am I going to get here?
Negative 195.50.
195.50 degrees Celsius, and it's a negative. Okay, now going this way, Celsius to Kelvin, what do I do? Yeah, 273.15. So I'm going to be positive.
It doesn't that we should have memorized the
Yeah,
temperature
that one, I
conversions?
would go back and forth. I would have it memorized.
The conversions for Celsius. Okay.
Celsius to Kelvin, I would have memorized because you're going to have to do it a lot.
Do we ever go back from Kelvin to Fahrenheit?
I'll have to look, and hopefully she's changed that problem on the test. I hate that conversion because that's when I would write down on my card. I cannot remember. 5/9, 9/5 times plus or minus 32. Yeah. Okay, so what do we get here?
329.15.
And I probably have these. And for Kelvin, you don't use the degree sign. It's just capital K. Okay? And I did show it, both of those. Okay? All right, let's go forward here. Now, I'm going to get to the laws. And I have given you some funny, silly ways to remember these laws. Okay? The ideal law. Ideal law. Mateo? Ideal law. Ideally, you're not a pervert.
Oh.
Oh, well, I hope so.
But it'll help you remember it. Look. The ideal law is PV equals NRC. Perv Pressure times volume equals moles times an R, which is a constant, times T. Now, I would, come on. Okay, the gas law constant, that is one I would write down. So gas law constant is one I would write down on my card. Because if you're off on the gas law constant, the rest of all your calculations are going to be messed up. Okay, pressure needs to be in atmospheres. This is the only gas law where it is specific what pressure you must be in. It must be in atmospheres. That's because of the constant. It must cancel out with the atmospheres and the constant. And if you know the constant, to perv nerd, you know what everything has to be in.
Wait, so the constant is that
The
specific?
R constant is that, 0.0821 atmospheres times liters divided by mole Kelvin. That is the constant. That tells you what everything unit-wise needs to be in. Volume has to be in liters. Pressure has to be in atmospheres. N is the number of moles. And then temperature must be in Kelvin. Do not put it in Celsius. Yes?
Is the 0.0821 over the fraction, or is it being times by the fraction?
The fraction is just the units. These are just the units on this.
So you're multiplying the number
So this
by
number has these units on it. And this is an older PowerPoint, so I didn't use the math wizard that shows it just next to it instead.
Okay, so if we put it in the calculator, you do
So
like
if you put it in your calculator, 0.0821. You can't put atmospheres and liters in, right?
Correct.
You can't put moles and Kelvin in. But you just put 0.0821.
And then multiply it by whatever numbers those
You
are.
need to,
So
yeah.
multiply it.
Okay, so let's do a calculation. Yep, did you not get it all down? Okay,
Sorry, what was the equation?
green on top.
Oh,
And again, I'm going to post this. Last year's is already up there. Okay? So, how to carry it out. Calculations with the ideal gas law. Step by step. First thing I do on any of these gas laws, pull everything out of the story problem. Because it is a story problem, just like math. And then you can throw the story problem away, right? So as I'm looking at this, I say, okay, how many moles of gas? I am looking for N. N equals question mark. Are contained in human breath that takes in. Here's my volume. I need that. Air of this. This is my pressure. It's in the right pressure. I'm good. The liters are the right liters. And here is my temperature, but it's not in the right unit. So when I get here, I'm going to add 273.15 and get the answer in Kelvin. I also know that I have R. That's what I do. Okay?
Can you slow down just a little bit?
Mm-hmm. So all I'm doing is just pulling everything out of the story problem. That's number one. Now I see kids that say, "Oh, I can just pull it out of the story problem. I don't have to write it down." Those are the kids that usually get B's and low B's and C's. The ones that write it down, take the time, so they've got it, and they make sure the right units. Those are my A's. Yes. R is one, remember, that you have to know. You have to memorize. It's a constant. Just like Avogadro's number was a constant, R, gas R, or gas constant is this. Okay? Now, if you want to, you can put it in and save it under G for gas constant. Yes.
So would you plug everything in so it'd be like 0.0821?
So we'll go to the next step. So the first step is just pulling everything out, right? And making sure they're in the right units. Then the next step, like I said, I would make sure that the temperature was in Kelvin. I include that in my first step, so I don't have this other little step. But I make sure everything's in the right units. Then you're going to look at the equation. I personally like to solve the equation for what I'm missing first before I plug everything in. If you don't, that's okay. You can plug everything in and solve for what you don't have. I don't care which way you do it. This is just the way I like to do it. Yes?
Can you go back to the R equals?
So the R you do need to memorize. It needs to be either on your card or it needs to be memorized, or you can put it in your calculator and save it under G.
Will always be labeled R.
R will always be the 0.0821. Yes. Okay, so we converted our Kelvin, solve for N because that's what we want to solve for, and plug everything in, get our answer. When you plug this into your calculator, this is another point of, oops, I did it wrong. Make sure when you hit the divide sign, you put that bottom all the way in parentheses. Either that or put in the bottom, hit enter, do 1 over x and then times through the top, like we used to before we had parentheses. Either way works, but make sure that bottom is in parentheses. You're dividing by that whole thing, not just dividing by 0.0821 and then timesing by 310. Okay, order of operations. Anybody questions on how to do this? That's okay. That's okay. I just want to make sure everybody's following the way we're thinking here. Okay, thumbs up, I'm getting this. Thumbs down, I'm not. Thumbs sideways, I'm not there.
I understand, just like I feel like I don't like it,
I'm
like
not
putting
gonna
it
remember.
in.
Okay, so you won't remember. That's okay. We're going to be doing several of these. I would write my gas laws on my 3x5 card, so I didn't have to remember what the ideal gas law is. But if you can remember the ideal gas law, you can get almost all the others. Yes.
So I'm just a little confused with the atmosphere, liters, mole, and then Kelvin.
That's
Like,
just
why
the
is
unit.
that?
That's just the unit right here.
Oh, that's just the
That's the
unit.
unit on that number.
Okay, what if
Yes.
I just tried to do it? It came out totally wrong.
So you would go, so put it in your calculator. I want you to try this in your calculator. You got the answer there. See if you can get it. Yes.
I don't think the answer's correct.
Don't think the answer's correct?
And the liters is not the same as
Okay.
the one previous.
That's right. Nope, it's wrong. I need one more zero.
Okay, help.
This should have one more zero in it.
Me.
Sorry.
Okay.
I should have one more zero in it.
Oh.
Please.
Did I miss a zero
Wait,
too?
there shouldn't be a zero after that too though.
There shouldn't be a zero after the two.
No.
You need
It's
two significant
196.
figures.
It's
Oh, you only need two?
well,
You need two significant figures. So when you look at it, you have 0.00196, right? Okay, so this is what your calculator shows you.
I thought there was zero.
Okay, that's calculator throw it, right?
Yeah.
The zeros don't count. Your significant figures.
Wait, why is there another zero?
The 1 and the 9 do. But I have to look at what's after that 9. It's a 6. It will round up, right? When it rounds up, that rounds. No. That's how I did it.
Why is it 0.05 liters?
So is it?
What?
Why is it 0.05 since it's 0.5 liters?
Is that what the problem was?
Yeah.
That is 0.5.
Please both go.
0.5 liters, so that's where it was the problem was, not the calculation. So this should have been 0.5 liters, that was there. So this one is right, and that would be
That is
wrong.
very.
Okay, sorry.
I'm sitting here like I didn't get an extra zero.
This is, I took this from the instructor's thing.
Blame the instructor.
I'm going to, because I did take it right from her. And so, you know, it is what it is.
So then wait, what?
What do you plug
Okay.
into the atmosphere meter?
Let's go on to another one.
Thank you.
It's not 10.
Okay,
Wait, 0.82.
yes, yes.
So when you put it in, when you do 1 times 0.5 divided by the 0.0821 times 310.
hmm
So I got 180.
Yeah, you're crazy.
That's because you didn't put the bottom in parentheses. So what happened is you took the 0.5, divided it by
That's a
0.018,
constant.
whatever,
Constant.
and then you times that answer by the 310.
So like
Don't worry about that. That's a unit.
So don't put these parentheses in. Don't put those parentheses in. Just do a times in between the two and do 1. If you keep getting the wrong answer, I would go back to the old-fashioned way where you times through the bottom, hit enter, hit 1 over x, and then times through the top. Then you don't have to worry about the parentheses. They'll work themselves out. Okay? All right, so let's talk about what happens when we have two sets of data. When we have two sets of data at different pressures, different things, they both have to equal R. If they both equal R, then we can set the two equal to each other. So we can take two perv nerd equations at different temperatures and situations and set them equal to each other.
Okay.
That is known as the combined gas law. So remember I told you get most of them from the ideal gas law. This is how you derive the combined gas law from the ideal gas law. Just by solve for R, set it equal to each other. On one side you have 1s, on the other side you have 2s. So two different situations, but they both have to equal R.
What if they both don't equal R? If
They have to. That's the law.
And if they don't?
They don't, then they aren't following the law.
Oh.
Okay?
Your calculation.
So this is a combined gas law. So they have not found a place where that doesn't happen yet. So just like in other theories and other laws, when we finally find something that doesn't follow the rules, what do we do? In science, we test it again to make sure that's true. And if it is true, then we have to make a new law, a new theory, and then work on a new law.
They have found it.
Right. So this has worked for everything we know so far.
Okay.
Yes.
So what would the gas look like if it doesn't look like that? Would it be like different?
This is taking a gas in two different situations. So maybe I have a gas at 1.5 atmospheres, and this is its volume, and this is the temperature. And I want to know what happens if I increase the temperature and the pressure of this, what's going to happen to my temperature? Now I can solve for the temperature of the new thing. Okay? So this is what this law is for. If I have two different scenarios going on, or I have one scenario and I want to change it, what's going to happen? What kind of volume am I going to do? What kind of pressure am I going to get? Okay, so I don't explode what I'm trying to control it. Okay? Okay, has everybody got combined gas law down?
Are you gonna show us like an example of like that?
I'll get to all of them yet. We'll do examples of all of them. Okay, the next one has to do, remember I told you, I'm going to go through a whole bunch of laws and then we're going to go practice a little thing and then we'll do some more practice. Boyles law. When you think of Boyles, think of water boiling, right? And that has to do with temperature, right? So we're going to take the original combined gas law, but we're going to drop out temperature. We're going to hold it constant. This is Boyles law. So Boyles law is said if I hold temperature constant, then my volume and pressures can change, and I have a relationship between the two. So if I hold temperature constant, these pressure and volume relate to each other. Okay, got it? We're going to hit a couple laws really quickly. Sometimes the N, you'll notice the N sort of drops out. The N we usually drop out because we're usually not fiddling with the moles. Because if you have a container and you're going to change the pressure and temperature, to put more mole in or take mole out is going to cause a problem with your volume. So usually we don't mess with that.
You said hold temperature constant means what?
Hold temperature constant is Boyles law. Okay? All right. And here's an example of Boyles law. And then we're going to do the little lab that we've got, part A. And then we'll come back to do some more laws. Because it sounds like you guys need a break. Okay, so how to use Boyles law. Again, looking at things as I do it. Now, here's the part that you need to be really careful with Boyles law and with the combined gas law. As you look at data in the story problem, you need to see if they are linked. If they are linked, they get the same number. If they are not linked, they get different. Okay, so if a 4-liter container, I know that's a volume. I'm going to call it volume 1 because it's the first volume I came to. Of helium gas. Okay, if I need to find a mass up, I can find helium. Just a big HE. But that's not one of my things in my law. Has a pressure. Here's my first pressure, and it is related to my volume, right? Because it said, here's my container and it has this pressure. What pressure? So now I'm looking for P2, my question mark. The gas exerted if the volume is increased to this. So this is V2. Again, pull out what you have. Notice as I went through, sometimes I rewrite it, sometimes I just circle it and say, okay, I've got everything here, and this is what I'm looking for. So I don't have to mess with it. But you're going to be taking a test on a computer. So it's really hard to circle that on the computer, right? So write it down on your scratch paper. What am I looking for? I'm looking for P2, right? So, is everything in the units I need?
Yes.
One thing that's nice with Boyles law and the combined gas law is the R drops out. So as long as the pressures are in the same pressure, as long as the volumes are in the same volume, then I can just use whatever they give me. Okay, temperature still has to be in Kelvin. Since Boyles law, the temperature drops out, I don't have to worry about that. Boyles law is P1 V1 equals P2 V2. I'm solving for P2. So I divide both sides by V2. Now I plug in. Again, if you want to plug in and then solve, that's okay. Because I know some kids do. They like to plug in the numbers and then solve. Whatever works for you. Okay? When you do that, plugging in, the nice thing about Boyles law is you don't have to use parentheses on the bottom because there's only one number. So I just go times the top, divide by the bottom, see if you're going to get the answer right. Plug it in.
I actually love
I got 20.
I still get one.
6.7 atmospheres is what you should have got.
So that's what P2 equals now?
So that's P2, yep.
And now we have everything.
Yep.
And is that where we would stop?
That's where you would stop. Yep. So here's the application. Everybody inhale. What's happening to your lungs? Expanding. Now exhale. You're squeezing, right? And things are coming out. So increase of volume, decrease of volume. The air is drawn into the lungs because of pressure. Okay? We exhale, the reverse happens. So you sort of need to know the application of Boyle's law, which would be breathing, right? Our diaphragm moving in and out. Okay? And we'll stop right here with Charles' law. I'm going to grab some things for us to play with and then do part A of the lab. It won't take very long. If you do not have a TI that has a port, come get one of these for me. I think there's enough for every two. To get one of these. I'm going to take these leftovers right here.
You're having an opinion, you're having a good life.
And then I'd like you to pick up one of these. I think I have some more balloons. So hopefully. Okay, go over and grab one person from each table. If you're a singlet, go in with the person that is a doublet.
I really hope that's we're screwed on or something.
First part, not part of love, but I want you to do one of these. You want the big ones? Everybody should have one of these. So you should have two per group of the big ones. So the big ones, they can all the way apart. If it has a balloon in it and it still works, you're good to go. If not, come get a little balloon from me and blow it up till it's about that big and put a snot on it. So you gotta take this off the end, or I won't let you take it all the way off. So take this off the end, then unplug it. You need a balloon from the other.
Wait, so if it's fine, do I put it back
If
together?
it's fine, put it back in. Put this back in halfway. And then put this on the end.
So once you take it out, you put it back in.
Just make sure it's not going to fall apart, that it's still decent, it's not.
How do I take this?
Everyone make it.
Okay, everybody got one, hold it up when you're done, so I know you're ready with this part. Put the cap back on,
So
you
cool.
put this plunger in about halfway.
It won't go in halfway.
You gotta take this off,
Oh.
put it in halfway, and put this back on.
I'm having trouble.
Everybody should have one in your hand. Every person should have one in their hand. Every person should have one in their hand.
Go get one. Miles.
Every person should have one in their hand. If you don't have a balloon in yours, come get it. It needs to be the big one. It needs to be the big one. My balloons are starting to get really now. Okay, has everybody got one? Holding their hand. The reason why I want every person to have one is you're experiencing this on your own so that you can hopefully get it into your head. You're actually experiencing it on your own. Okay. Every person should have one of these big ones. Every person. Every person.
Wait, can I get it?
Okay. Holding it above your head when you got it. Show me.
No, I can't.
That it's ready.
I have no idea what I'm doing.
Show me that it's ready. You've got a plug on the end. You've got it halfway up, open. Still waiting for a couple. It needs to be a big one though, not the little one. Don't put it in the little one.
I have a trophy.
Don't put it in the little one. That's important. Okay, here we go. I want you to squeeze it as far as you can squeeze it in. Okay? So squeeze it in. If you want to put it on the table or do this, tell me what's happening to the balloon.
It's squished.
Nothing.
Oh, it's stuck now.
When you push it down, what's happening to the balloon? So you got to make it so you can see what's happening to the balloon while you
Oh, like
push
the
it.
hair's like coming out. It's like holding in the middle.
Whoa.
Yeah.
Oh my gosh.
Okay, can you get it down to the very bottom?
No.
Okay, why?
There's gas in there.
Because the gas is in there, it can be compressed, but only so far, right? Okay, now I want you to go the opposite way. Make it bigger. Give it more volume. What happens?
It kind of
Some of you are really strong and pulling all the way out. You have to undo the thing. What's happening? What's happening?
It kind of blows up.
It blows up a little bit, right? It blows up a little bit.
Oh, she kind of.
It blows up. Or I can make it shrink. This is Boyle's law. This is what's happening with Boyle's law. Okay, this is a visual. Now, what you're going to do is you're going to do a lab where it actually measures the pressure inside the syringe. We're going to use a smaller syringe. I wanted you to have a visual so you can see what's going on. Keep this sort of by you while you're doing the lab so you can remember, okay, should the pressure be going up or should the pressure be going down? Which one, where is it going down? Where's the pressure going down? When the volume becomes bigger, right? Because the balloon's blowing up. When's the pressure increasing? When you're pushing it because now it's volume's going low. Okay, now you're working in pairs. It's going to take two of you. Grab your syringe. Grab your pressure sensor.
Okay, I'm gonna.
Okay, you need your lab in front of you and you need something to write down. This is important. I'm going to walk you through it. We're going to do it together. When we're done, we'll put it away. And then you can do the calculations. Okay.
We're turning this in, right?
Yep.
Okay. Kyle, will you take the data? Is that number 11?
I'll make up
I don't know what this is.
Or the lab.
Okay, take the syringe and put it to 10 centimeters. So it needs to be the one that, not these ones. Don't open the one that doesn't say BD. Those are for the next part for Charles. So just the ones in the boxes. Just the ones in the boxes. There should be syringes this size of the box.
Miss Hal, is it this thing?
Yes, take it apart.
Oh,
Unscrew it. Kind of his was attached to some other thing.
Oh, wait. Wait, ready?
What does it look like?
Who needed a syringe? Anybody need a syringe?
Is this part A?
Okay, so if it's attached to something, undo it.
What do you put the thing out?
So everybody got a small syringe.
Other than we put it up.
You don't have a small syringe?
All of us have to have one.
So the last one should be over here on top of the sheet. If you weren't here to pick the lab up, I think there's more copies on the file cabinet above Weaver State. Okay. So it should just be a syringe like this when you go to put it in. Okay? Before you put it in, you want to pull it down till the top black line is at 10. So the top black line, make it right at 10.
top, wait, which?
Top is in.
I
The
have-
top on the nipple side of the plunger.
Okay.
Okay? Yes. I'm going to show you just a second. Can you go the rough? This is the barometer. Okay. Now this is important. Please listen because these are spending and if you do this wrong, you'll correct this. Don't touch anything until I tell you to. Okay, we haven't attached anything until I tell you. You've got this at 10. Right? And there's a purpose, reason why I'm making you go through this, because we've lost a lot of these because of this. Okay, you're going to take your barometer, just took away your gas pressure sensor, you're going to put this in. Now it's really important that you only snug it till it first starts to get snug. Don't wrench it on. Okay, just till it first starts to get snug. Okay, then you're going to take this and you're going to hook it on the very top. Okay. Well, write down it on a separate piece of paper, and I will see if I can print some. Actually, Okay, then plug it into the Easy Link.
What units do we need to send?
Then I want you to plug it into the calculator. Okay, has everybody got it? Yes.
Do we need to put this, what volume pressure in kPa?
Yes. Okay. Then plug it into the calculator. The calculator should turn on and come up to kPa. I'm hoping.
Yeah, that's
Measuring it in
a
kPa.
Oh, yeah, I'm getting KPA.
Okay. Now this is important. In order for your graph to be right, you don't want to take a reading yet. Okay? In order for your graph to be able to print really nice and pretty, to be able to take list 1 and list 2, take it to a computer and keep them and make it really nice and pretty, you want to go with the lowest setting, the lowest volume that you're going to do first. So you're going to take, and the next person is going to squish this down as far as they can get it and hold it and tell you what volume they're doing. The other person is reading the calculator and writing down in your data table what the volume is, what the pressure is in kPa. The volume, so we were at 10, you're going to squish it down as far as you can. And you're going to write it down. And you're going to want, this is the easiest way.
We actually tried this one. Oh wait, never mind. But wait, no, no,
So as soon as these guys are broken, trade it out.
Okay, so now you read the calculator. I push in and see where it and we go back to 3.
Okay, so then what you hit as hard as possible,
I can get
then
it.
come out a little bit. Take another reading. Come out a little bit. Take another reading. You've got how many places you need to take readings? You want to fill those all up. The last reading that you want is right at 20.
Oh, we're not
Last reading you want is right at 20. So start low, come all the way up.
So right now, what's on the calculator in kPa? What I tell you, my right now.
Okay, so 0, 0, 0. So start at 10 and then try to push it down to 2, 4, 6.
no writing. Oh, because we started at 10.
I'm really confused.
Do you agree?
So this is supposed to start at 2.
So you don't want 10. You want just pushing down.
Okay, now,
Remember, you want to set it as far as you can.
read that. No, hold on, that's not good.
Yeah, these guys, if they have low battery, they will not read right. So you'll end up seeing temperature and it won't change, or it just won't read. So you'll keep rolling when you.
I have a question. What pressure should be normal?
So you gotta take the first reading.
Okay. Right back pressure.
First one is 1,
Yeah, 10
2, 3, 5. No. Guys, what did I tell you? Push it down as close to 0 as you can and then work your way out. So your first reading should be close to 0. We started at 10 because we needed to have some gas in there, right? But we want to start as close to 0 and work our way out until we get to 20 as our last reading.
So we're starting at 10 and then.
Oh, wait.
So you're going to start at 10 and you would write that down. Look it up.
No, that
Push
broke
it
it.
down.
No.
One of my questions, where do we read?
So read.
What section?
Oh, okay, I'm at 1, 2, he has to read really fast. Yeah, and you gotta do it quickly. Guys, you can't spend a lot of time. You gotta go down and the person that's doing the syringe says, okay, I'm at 2, and the one that's reading the calculator reads it right then. And then, okay, I'm at 3, read it right then. So it's gotta be fast. You can't do it yourself, you gotta make sure it's fast.
Where do we put it at on the graph? Like what section are we writing it down to?
So the first 2 columns.
So the volume is the syringe.
You wanna go to 10 or 20, sorry, you wanna go to 20.
I think I've got a broken one.
Okay, so
So volume volume syringe.
you want to have,
Yeah.
so you've got 8 in there, I've got another 6. I would just figured it out 20. Because I said between here and here, it's 0 to 20. And this is exactly 0, like you have it right at 0. No, if you move on at all, that just makes sense. So you probably
Just press it
want
all the way down.
yours isn't changing, that is a problem.
So do 2, 4,
If you hear a click, did that mean it broke?
10, and then do
So
15. Because otherwise we ain't
Alright, when you are finished, make sure everything gets done. You've got about 8 minutes.
This how?
Doesn't take long, get it done, and then you can do your graph, you can do calculations, do everything.
I push this all the way in, I get it down there. The air leaks out.
Right, so you've got an air leak. So you're gonna have to watch that, and as quickly as you get it there, so you have to reset it.
So I think it's 231.
So you will go to I can move it to 4.
Okay.
So there's 4.
Are you ready? 231.
So that's not necessarily where we can get to, it's where how close to it.
Yes. Okay, do we have any other issues? Anybody else need help?
It's like my third time
Okay.
And you can go ahead and leave your food like this.
4 was at 231, right? 7. 12. 17. 15. 48. 18.
Okay, guys, on my calculators, if you don't quit before you unplug the sensor, oftentimes it doesn't like that. It's crazy.
Well, it did it froze before we
Now what happens if I hook this thing into it?
Teamwork.
So if we need the chance with not trying it.
You guys kind of kind of what our dot boy